Okay, so this is 2011, and it's question 1 on paper 1, and it's algebra. Okay, so first thing you're asked to do, quite a tricky A part. So you're asked to just simplify it. So what you're going to do is you're going to create an LCM. And the LCM in this instance will be x minus 1, x plus 1. And the reason I'm going to use that is because this here is also the difference of two squares. And the normal procedure for LCMs is that you not just use a common multiple, but that you use the lowest one possible. And as we can see in the first term, what's underneath the line, the x minus 1, which is here, that will divide into what I've chosen as my LCM, as will the denominator of the second term. So we'll begin, so bottom into bottom, so x minus 1 from the first term into what's underneath my line, so that'll be x plus 1 by x plus 1, minus, again, bottom into bottom, so this time it's going to be x minus 1, x minus 1, and of course because it's the difference of two squares, it's just going to be minus 4 times 1. Be asked to tidy all of that up, of course. Just make sure, just at this point here, that you watch the minus. Okay, watch what you're doing with that. Multiply the brackets out first, then multiply the minus in, I think is the best way to deal with it. Just on the top there, factorise out the 4. Of course they'll cancel. So your answer is 4 over x plus 1. Okay, so moving on to the B part. The B part 1. The B part 1 is just the factor theorem. So it's not too difficult. You either know it or you don't. So I'll just write out the factor theorem for you. You start by saying let f of x and you're going to look for f of k. And then what you're going to do is you're going to subtract them. So just underneath the line there, so you'll have ax squared minus ak squared plus bx minus bk plus c minus c, which of course they will cancel. Going a little step further, factorise out the a, so that's going to be x squared minus k squared. Factorise a little further. If you have a look there, you've got two common factors, or just, sorry, a common factor in each term. So I'm going to take it out. And once you're at that stage, because x minus k is multiplying in, what you can say is that x minus k is a factor but you're told in the beginning part of the question that f of k is actually equal to 0. So in other words, x minus k of f of x. And that finishes the proof. Okay, the B part 2. This would have thrown a few people. The B part 2, you're told x plus k is a factor of g of x. So you're asked, the factor theorem also holds for polynomials of higher degree, which we already know. So we can, in a lot of ways you can ignore that sentence. Find the values of n for which f of k is a factor of the polynomial. The bit that's important for this question, the bit that will give us direction, is the bit that says find the values of n for which that is a factor. That's the important. That gives us some direction. It tells us that our answer should be in the form n equals something, and maybe several somethings, and we know it's several somethings because it's values of n, and we know that we have a starting point. It tells us that x plus k is a factor, which means x is equal to minus k. And that when I sub that in, I'll get 0. So we have to make a decision as to what we have to try and sub it into. So you're going to sub it into g of x, and you're told g of x is equal to x to the n plus k to the n, and you're told k can't start with 0. So we have to try and figure out what values of n such that as they vary, when we sub them in, the answer is going to equal to 0. So let's start with a couple of examples. So let's try n is equal to 1. So if n is equal to 1, sorry, by the way, just before, x is equal to minus k, so we're going to change that x to the n to minus k to the n plus k to the n. And when I make that change, I know that the answer should be 0. So let's try n is equal to 1. We'll have minus k to the power of 1 plus k to the power of 1. So that's equal to 0. So that's going to work for us. N is equal to 2 minus k squared plus k squared. That won't equal to 0. N equals to 3. That will equal to 0 because that minus cubed there, that will end up with minus k cubed plus k cubed. So that's equal to 0. So that's going to work. N equals to 4. Won't equal to 0. That will work. From that, what it looks like, we can make a little bit of a jump. We can say that whenever n is odd, x plus k is a factor. And there's your answer for it. Moving on to the C part. So just so that we're clear on that B part 2, what's going on. We're subbing in minus k for x because it's a factor. So we're going to sub it in here. Leave the n where it is. And then we're testing different values of n to see if we can make the equation balance. In other words, to make the left hand side equal to the right hand side. And that's how we generate our set of solutions. Okay, next part of the question, you're asked, you're told x minus a all squared. You're told it's a factor. That means you're going to go straight in for your division. First step is going to be multiply this out. So x squared minus 2ax plus a squared, and then you're going to set about doing some division. that's 2x cubed minus 5ax squared plus 8abx minus 36a. So begin, so x squared into the first term, so first and the first, x squared into 2x cubed is going to give me 2x, and then I'm going to multiply it back down. Make sure there, a common mistake would be to put the, see where it says a squared, to make that an x squared. Quite a common mistake, or sometimes people leave it out. So draw your line, change all of the signs. Sometimes it helps just to get rid of these ones so that there's no mistakes. Our first term is going to cancel, and you'll be left with minus 5a plus 4a. So that's minus 1a x squared, or just minus ax squared. The next bit is going to get a little bit bigger, and maybe sometimes if you just take a little aside, so you've got 8abx minus 2a squared x. All you're really doing is you're factorizing out the x, and that's what's going to go back in. And the 36a drops down. And then you'll begin the process again. So a squared into minus a, sorry, x squared into minus ax squared, so that's going to be minus a, and you're going to multiply everything back down. That'll be a plus 2a squared x minus a cubed. Draw the line, change all of the signs. Of course, the first term will cancel for us, and you'll say then, of course, what that should equal to then, because we know it's a factor, we know that the result will be 0x plus 0. So that allows us to create some equations. We know that 8ab minus 2a squared will equal to 0. And we know that minus 36a plus a cubed, we know that that's going to equal to 0. So taking this first one, let's divide across by 2, so 4ab minus a squared, that's equal to 0. And if we look to try and factorize out here, and it looks like we're at a little bit of a loss. But what you need to have a look at here is, if we just take the right hand side, we know that a would equal to 0, and that minus 36 plus a squared will equal to 0. We reject, because we're told that this can't be an answer in the question. So that means solving this part of the equation, a is going to equal to plus or minus 6. Now that we know what a is, we can take those values and sub them back in here and solve out for b. When you do that, if a is equal to 6, the b value that you should get is 3. And when a is equal to minus 6, the b value is minus 3.